Right, so let's look at what they gave us for this problem. They gave us the graph of f, so that's the original function, and then they gave us the graph of f prime, so that is the derivative. So we have the graph of f, and we have the graph of its derivative. But we don't have an actual function to work with. All we have are those graphs. So we can't actually like take a derivative or an antiderivative because we don't have a function. All we have are these two graphs given. So letter A, find the average rate of change of f over the interval -1 to 4. Okay, so hey guys, what does average rate of change mean that we are trying to find? What is average rate of change asking for? Good, nice job guys, slope, perfect. It is regular old slope. All right, now we want to go from -1 to 4. So I need a point, nice job guys, perfect. All right, I need a point for -1 and I need a point for 4. And so we're just going to get those from the graph of f. It says average rate of change of f, so this is the graph we're looking at. So -1 is down here at -2, and 4 is right here at 1. So I just got those points from the graph, and then we're just gonna slope them, put them into slope formula. So it'll be 1 plus 2, 1 minus -2 over 4 plus 1. And you can stop there, but I am going to keep going because there's like a secondary question for this one. So I am going to simplify this down. That would just be 3/5. But technically you can stop there. You don't have to simplify it any further. Like that's a totally valid answer. But here's the second question. For how many values? So you don't need to find them, just how many are there? For how many values of x in this interval -1 to 4 does the instantaneous rate of change of f equal this average rate of change? So instantaneous rate of change, that means derivative. So now we're looking at this graph of f prime, and we want to know how many times that graph equals 3/5. So let me just draw in 3/5. I mean, 3/5 would be between 0 and 1. It would be in here somewhere. So like here's 3/5, close enough. How many times does that intersect the graph? That's all that they're asking for. So how many? What's the answer? How many have we got, guys? Dos, dos, 2, duo, deux, okay, zwei, 2 times, all right? So this derivative equals 3/5 2 times on that interval -1 to 4. And on the answer key, I accidentally wrote 3/4. I'm really sorry. I didn't retake the picture. I'm sorry. It should be 3/5. Copy error. I'm very, very sorry. All right, but 2 times is how many times that equals that. I'm going to go ahead and erase that so it's not in there for the next part of the problem. All right, letter B, write an equation of the tangent line at 1. Okay, hey guys, what 2 things do I need to write an equation? I like these. These are good review questions for us to go over. We need 2 things. What 2 things do we need to write an equation? Good, point and slope, perfect. Point and slope, all right? And we want the point to be at 1. That's our point of tangency. So it's going to be 1 something, and then we're going to need a slope. All right, so the point comes from the graph of f. So we just need to find 1 whatever. So here's 1 on the graph, that's at 2. So we have the point 1, 2. Slope comes from the derivative. So that's f prime of 1. And so over here, if we find 1 on the derivative graph, that is at -2. So again, the point comes from the original graph, slope comes from the derivative. Derivative means slope. And then you just put that together into the equation. So it'll be y minus 2, it's y minus your y value, equals your slope, and then x minus 1. Cool, I like that one. It wasn't too bad. All right, letter C, for each of these 2 limits, find the value or give a reason why it does not exist. You have to notice this pattern. This was back from unit 2. Remember, limit as x goes to c, f of x minus f of c over x minus c. That was one of our derivative patterns. This is the derivative at that point. So this means derivative at 2, and this means derivative at 3. So you just have to recognize that that pattern is following this, right? So limit as x goes to 2, f of x minus f of 2 over x minus 2. That means the derivative at 2. So we're either going to, have an answer, or there won't be one and we have to explain why not. All right, so we're going to look at the derivative graph at 2 and see if we can get an answer there. So here's the derivative graph, here's 2, and yes, there's a point there, it's 2, 1. So that answer is 1. So easy peasy, that's all we have to do for that. And then for the second one, it's the exact same thing except with a 3. So this is going to be the derivative at 3. And so again, we're going to go to the derivative graph and see if we can get an answer there, or if not, we'll have to explain why not. Spoiler alert, usually if one of them works, the other one doesn't. They usually give like one of each. All right, so here's our derivative graph. Here's 3. I can't get an answer there. There's holes. And if you go to the graph of f, what is the problem at 3? Why can't we get a derivative at 3? Because we're going to have to say does not exist and then like due to some reason. So what's the problem here? Like, why can't I get a derivative at 3? And yeah, good, nice job. Sharp point, sharp edge. There's a corner. Okay, so we're going to say does not exist, not differentiable due to sharp edge. Cool, so one of them worked, one of them didn't. All right, and then last one, D, let G be the function defined by e to the x times f of x, find G prime of 0. Okay, so cool, we're gonna find the derivative and then we're gonna plug in 0. So easy enough. What derivative rule do we need for this? Since it's e to the x times f of x, what derivative rule are we gonna need for this? And good, that is correct. I was hoping to get a few more responses there, but yes, product rule. You have two things being multiplied. So e to the x is the first function, f of x is the second function, right? So it would be first times derivative of the second. So derivative of f is f prime. So first times derivative of the second plus the second times derivative of the first. And if they're going to give you a function in there, e to the x is the best one because it's its own derivative. All right, then all we have to do is plug in 0. So e to the 0 power is 1. And then f prime of 0. So we're going to go to the derivative graph and look for 0 something. So here's the derivative graph. 0 is at 1. So that will be 1 for that. All right, plus f of 0. So now we're going to go to the graph of f and look for 0. And that is at 3. So that is going to be 3. And yeah, I agree. Every time I see e to the x, I'm like, okay, good, this is not going to be so bad. All right, and then again, e to the 0 is 1. And you don't have to simplify that down. You can just leave it like that. But if you did want to simplify it down, it's just 1 plus 3 sub 4.